Hello and welcome to TGIK live at the Heptio studios here in Seattle, Washington. I am your host today, Kris Nova. It is a lovely Friday afternoon. I'm here alone in the Heptio office.
Hello and welcome
to
TGIK
I have my sound on.
at the,
1 second.
Heptio studios here in Seattle, Washington. I am your host today, Kris Nova.
Oh, this is
It
great.
is a lovely Friday afternoon. I'm here alone in the Heptio office.
That was like going to get recursive for a second, like my voice talking into my voice, talking into my voice, talking into my voice. Anyway, let's do a double take. I'm here alone at the office. Thankfully, nobody was here to see that. And so we're hanging out doing TGIK. So we all know my favorite part of the TGIK episode is here at the beginning when I get to say hello to folks and see who's all here in the chat. And it looks like our chat's a little bit kind of weird today. So I had to reinstall OBS, and I just reconfigured everything. So I might want to turn that chat screen off, or I might have to dial it back in a little bit. We do a weird thing with CSS where it kind of like mimics a browser, and that's how we get the chat in the YouTube stream here. So I don't know, maybe it's this new version of OBS that I downloaded that is doing something weird with the CSS. Anyway, I'm pulling up the chat really quick, so give me 1 second. How is everyone doing today? I know last week was an exciting week. For us, it was KubeCon, and this is our first week back. And for those of you who don't know, Joe and I did a little bit of live TGIK at KubeCon, and because of some technical concerns, we didn't actually broadcast those, or I think we recorded them, so we might be able to release them later. But I had some really good feedback on the 2 live TGIKs that I did, one of which was on this new project called Kubernetes and Docker, and the other one was on etcd. And so we only had about 45 minutes at the actual conference to do each one of these TGIKs, so they were sort of like these short little mini episodes. So we're going to munch 2 of those together to make one TGIK proper episode for today. So anyway, I got the chat pulled up. Let's see what's been going on here. It looks like folks have already said a lot, so I'm going to try to play catch up and see who's here and what everyone has been talking about. So Olav was our first one this week. He says, Happy Friday from Denmark. We have a waving from Jesus. We have Bob. Happy holidays from Hollywood, California, a nice 20 degrees Celsius. Thanks for using the metric system, Bob. Yeah, that was Bob. I really appreciate that. I always tell people, I'm going to go set the room temperature to 21, and they look at me like I'm crazy. So anyway, reporting in for duty from Bogota, 62 Fahrenheit, 17 Celsius. Looks like Jose had a quick question, one quick question. Any tips for application logging in K8s? And it looks like Olav had a little back and forth. So I'm going to breeze past that. It looks like Elisiano, good to see you again. Howdy, folks. Happy holidays. It was nice to see Chris and Joe at KubeCon. It was good to see you, too. Actually, I probably met 20 or 30 people who came up to me and was like, hi, you don't know me, but I watch TGIK every week. And I'm like, oh, cool. Have we ever interacted before? And they're like, no, I don't ever say anything. So I'm looking at all of you folks right now. If you don't usually say stuff in the chat, at least introduce yourself and say hi. You are welcome, and we do really appreciate when you get involved and ask questions and help me out. It makes the show a lot more fun. Okay, so we have Ed from Starbucks. Miguel, hello, everyone. We have, I'm going to butcher this, Macbool. Hello, everyone. Jose says, hi from New Zealand. Sorry. Miguel says, how are you doing, Chris? Marco says, hello. Marco, good to see you, too. It was good to see you, Marco, and thanks again for all the hard work you do, Marco. You do a lot in open source, and we all appreciate it. Wilder, hello. We have Dubstep Chris Hype. I'm assuming that's Bergdus. That was a comment about how my voice was repeating itself. I think we just needed some more womp womps. Always need more womp womps, right? Elisiano says the chat is cut out on the right. Yeah, so that's what I was talking about earlier. How can I fix this? Maybe I can just fix it right now. I don't know. How do I? This is going to turn into TGIK on how to OBS. Watch. No, I don't think I'll be able to do it super quick. Anyway, I'm sorry about the chat. Well, if we have time at the end, maybe we can tinker with it. Or if anybody wants to look up how to do a quick resize, that would be helpful as well. Happy Friday from Toronto. Hello from Berlin, Germany. Happy holidays. Saeed, hello from London. Mohammed, happy holidays from New York. Burgess says, lurking from a foggy -1 degrees Celsius in Iceland. So I will be in Iceland for 10 days. I leave on Monday. I'm going to be mountain climbing and ice climbing all of the beautiful frozen waterfalls while I'm there. But I am a little bit nervous about, going to a new country in the winter. There's been a lot of avalanche activity here in the Pacific Northwest, but I've been trying to track the weather in Iceland pretty regularly, and it actually looks like it's been pretty good. I'm a little bit bummed to hear it's -1 though. Hopefully it's not that bad when we land in Reykjavik. But yeah, I'm really pumped for Iceland. That's like my Christmas holiday present to myself. So hi from Tunisia, howdy from New Jersey, hi from Madison, hi from Dusseldorf, Germany. Wow, we have a lot of people joining from overseas. Hello from Berlin. Yo, Chris, how are you? Robert, good to see you too. Robert, he plays drums in the GopherCon band, and I'm usually just like, the like emo chick with an acoustic guitar playing rhythm guitar. So David says, good afternoon from Eugene, Oregon, and Arum says, hello from Paris. Okay. So I have a lot to go over before we get into Kind and etcd, so we're going to jump right into this. So let's see, I want to go to my screen and my face. Oh, the chat's still going to be there. This is going to drive me nuts. Let's see, what are properties? There is height and width. How do I change this? Let's just try. Properties, let's do width set to 200. Let's see what this does. Whoop. That might be a little bit better. I think that's at least a little bit readable. Let me know what it looks like for folks on your end, if that looks okay. Just somebody give me a thumbs up or something. I think it's a little bit more legible now. Okay, so anyway, here we have our HackMD. Since George is not here, I'm going to copy this, and I'm going to go down here to my chat, and let's see if that worked. Yes. Okay, so there's a link in chat now. Oh, and it looks like we're cutting folks off. Let me see what I can do here. Properties. So for height, let's do 600. See what this looks like. Close. I don't think it's scrolling now, but it's a little bit better. Let's just keep it here. I think that's the best we're gonna get. Anyway, there's my Heptio link I just did. And that's the HackMD. So if you want to take notes, George isn't here to help out, so it would be nice if somebody else wanted to volunteer. We can give away like some theme to say thank you, and we usually do like a giveaway every week, but I don't know how to set that up, so we're going to be skipping it this week. So if you want a chance to win some sweet swag, help out, take some notes, ping me afterwards, let me know that you were able to help out, and we will go from there. Okay, so anyway, the first thing that we have is we have these reference links that we do every week. And this is supposed to be kind of like a what's new in TGIK, or like what happened in Kubernetes, or like what happened at this conference. And it's kind of like the daily, weekly reporting with your host here on TGIK. So last week was KubeCon, so a lot went down. So I'm going to talk a little bit about kind of what the conference was like, give some folks an idea, if you weren't there, what it was like for me. The first one we want to talk about is this playlist. So the CNCF is really, really great about putting up all of the KubeCon talks, and they had some of these up and online like the day after the conference. So most conferences I've seen, like the turnaround is like several weeks. This is, in some cases several hours. But you can come through. All of these videos are really high quality. They like do a good job at like mapping the person standing at the podium to the actual screen, and they kind of flip back and forth. And there's like 340 of these, so you could sit down and just watch Kubernetes videos for like days on end. But I went through and I picked out a handful of ones from some of our all-star developers and developer advocate type people here at Heptio. So because I'm the only one here in the office today, I'm going to pat myself on the back, and we're going to talk about my talk first, because that's just the type of person I am. And MacBull says, Julia's talk was great. MacBull actually brings up a really good point. If you go to the TGIK repository, I actually started 2 new issues that I wanted to use for today's episode. The first one here is Favorite Talks of KubeCon Seattle 2018. So I'm going to tweet about this afterwards. We'll tweet about it from the Heptio account. If you have a video that you liked or you think would be good for folks to watch, this is an open source place to come and just track that and maybe leave some commentary about videos, or give it a thumbs up if you really enjoyed it. So after the episode, I'm going to come in and add the talks that I'm about to feature, and I'll give them all a thumbs up to say that I like them. But if you have any talks that you like, feel free to come here and add it here, and you can just use this as a reference, and hopefully some folks will contribute to it, and we can actually get some good feedback here. So this is a good place to do that. Okay, so let's go back to our HackMD. So cluster bleep. So this is a talk that I have been wanting to get. This is the second time I've made myself talk back into the camera. This is a talk that I really wanted to give. I was going to give it earlier this year, but there were some issues with my flight, and I wasn't able to give it. But I've actually been working on this talk for a very long time. So it's one of my more mature talks, but this was actually the first time I had ever given it. And the whole point of the talk is to sort of build empathy for folks who may or may not be struggling with Kubernetes. We do this a lot here at Heptio when we actually do TGIK. I feel like there's a big part of TGIK that folks like that's just like me or Joe, like, how the heck do I do this thing? And we're just trying to figure it out. And so that's sort of the empathy that we wanted to relay here as well. So it looks like Herman says, I really like the keynote of Kelsey. Your talk about cluster bleep and the Reddit talk was really an inspiration. Thank you for your comment, Herman. Elisiano says, LOL, cluster bleep is one of the best talks I've attended at KubeCon. Well done, Kris. Thank you. Yeah, this was a lot of fun to give, and there's some good concrete examples in here of ways that folks have done really innocent things that you wouldn't think would be catastrophic that turned into catastrophic problems. And then we talk about how we recovered from it and how we are going to learn from those mistakes and actually not make them happen again. And today on the Kubernetes and Docker, we're actually going to look at what it would look like to implement a regression for the CVE that we talked about in my presentation here that is up on the screen right now, and actually look at building a unit test specific to the CVE and what that would look like. So it's kind of exciting to actually be able to do one of these live and actually give folks a little bit of advice and an example of how you could go and actually start to look at your clusters and verify that your clusters are doing exactly what you want them to and nothing they're not. Okay, so that's my little spiel on cluster bleep. You can come here and you can go to settings and you can set, let's see where it is, speed here. You can go speed to 2 times 2, and then that's going to bring this down to about a 12-minute video. So you can like watch this pretty quickly at your desk, or if you have some free time, feel free to check it out. Okay, so this next one is a really good one by one of our engineers here. His name's Matt Moyer, and he did a talk along with Evan Gilman about scrutinizing Spire to sensibility string Spiffy security. So that's a lot of S's. So what is that? That's alliteration, right? I don't know. I didn't do very well in English in school. But there's a lot of S's here, and I remember seeing this talk kind of evolve over time. Moyer jumped on the phone with me and gave me like a quick like demo for it and asked for some feedback. And then I actually got to go and watch it live and see how the talk evolved. And it's always really exciting to see, especially with security talks, the things that people choose to change as they grow and as it gets better. So this is just a really solid talk that talks about like the architecture of Spiffy. It explains what Spiffy is and talks about how like we can better harden Spiffy and actually make improvements along the way. And it's just overall really interesting security talk. I feel like my cluster bleep talk got a little bit into security, but not nearly as deep as this goes. So if you're into that, come check that one out. Next, this one is another one that I got to watch evolve. Liz and I talked before KubeCon as well, and I got to get like the behind-the-scenes sneak peek of Liz's talk here. I feel like this is one of the best examples of a 5-minute lightning talk. 5 minutes are really kind of hard as a public speaker to try to convey a lot or make a meaningful point or tell a meaningful story. And I feel like Liz does all that. She's able to tell a story. She's able to explain the technology concretely. She's able to keep your attention the entire time. And I learned so much, not only about Postgres, but how people are doing really interesting things with Kubernetes. Liz basically explains, and you can go watch the talk, and I encourage you to do that because it's a stellar talk. But Liz talks about how she was able to do some things with Postgres and actually hook it up to Kubernetes and actually use Postgres as like a client to Kubernetes. It's pretty exciting. So that's Liz's talk. And moving on, I wanted to credit one of my good friends. His name's Peter, and he has this project called Faces of Open Source. Earlier this year, I went and did a presentation in Raleigh, North Carolina, and he was kind enough to invite me into the studio that he had set up there at the hotel. And he has photographed some really famous, notable people. Like here's a picture of Linus Torvalds. Over here we have Kim Thompson, who helped create the Go programming language. And this guy is a legend in his own right. And let's see, how do we go back? Oh, I don't know. This site's a bit weird. But you can come through. Oh, there it is. It was like a JavaScript thing. You can come through and you can see all of these really great photographs of really notable software engineers. And I really like it because it kind of brings like a face to like the people making the software that we all run every day happen. And if you scroll all the way down to the bottom, well, actually, let's poke at a few of our friends here. So here's Kelsey Hightower, looking awesome. And then I think Jesse's in here somewhere as well. And then, yeah, there's Jesse. And then there's just a bunch of really notable people. There's Camille and a few others. Anyway, if you scroll all the way down to the bottom, here's me, and I was like, it's such an honor to get on this list and be like considered for a notable open source achievement. Plus, it's actually a really dope picture of me, and I just really like that in general. So I'll be using this moving forward. Anyway, there's a book you can order if you're interested. This is some great photography, and it's got some really interesting stories about the technology behind the people, and not the other way around. Because I always feel like we learn about a tool, and then we learn about the people, and this was kind of spinning that on its head. So this is a cool project as well. Okay, last but not least, we have Harbor version 1.7 is now in GA. This was exciting to me because this actually came to me via my VMware email. So I didn't actually go out and find this. I just got set up with my new VMware email. And I'm scrolling through my inbox, and all of a sudden it's like, oh, this project is now GA. And I'm like, oh yeah, Duffy totally did a TGIK on Harbor, and I'm hearing about it via VMware. So that was just really rad to kind of like have that at runtime. But anyway, there's a lot of new features here. You can come in, you can read about them. They do a good job at referencing people. And for those folks who don't know, Harbor is a way to not only store and upload your container images, but also scans them and helps you with security on your journey to building better containers. So anyway, Harbor v 1.7 is released. Moving on, we have tracking KubeCon talks. So this is the link to the GitHub issue that I just showed folks. Looks like people are in chat. Let's see what they said. Bergda says, OFC, they hide the cutie at the bottom. And Michael says, of course, Linus first. Yeah, of course, Linus first. I bet that was... Anyway, I'm not going to make a comment there. But yeah, Linus... I mean, he invented Linux, like, come on. And he, like, still is an active maintainer. That's pretty rad. Anyway, tracking KubeCon talks. That's the GitHub issue we just looked at. I'll pull it up again while I drink my tea just for good measure to see if anybody has commented yet. Comment on my issue. Okay, next. So Joe doesn't know I'm doing this yet, and YOLO. But now that we're at VMware, I think it might be a little bit easier for me to get like some support and maybe possibly even some funding for helping out with TGIK that's been so successful over the past like 2 years. I mean, can you believe it? We're already on episode 60. Joe has done a ton of these. I've done a ton of these. And now that we're VMware, it might be cool to like revisit TGIK for 2019 and see if we can't like step up our game a little bit. Like we could get a sweet, cool intro, or maybe we can have some music or something. And maybe we can start to do like multi-people and figure out how to get OBS up and running. So if you have any feedback at all or any ideas for what would be really rad for something we could bring to TGIK in 2019 as we move into the new year and as we transition into VMware, feel free to come drop your ideas here. And again, you can use the thumbs up emoji to come and vote. So feel free to go do that. Okay, last, before we jump into Kubernetes and Docker and etcd, I guess this is it. Okay, so let's just jump right in to the reason we're all here. We'll start with Kubernetes and Docker, see how we're doing on time, and jump into etcd at the end. And I might just do a little bit of etcd, and maybe we can do like a more involved, deeper etcd episode later. But there is just one primitive that I wanted to mention, and I think it's important that people start understanding etcd, especially because it's moved into the CNCF as one of the official projects, and that was announced at KubeCon last week. So that was the inspiration for why I wanted to talk about etcd and actually explain this mysterious database that is the powerhouse behind Kubernetes. Let's see what folks are saying. There is another nice registry project from SUSE called Portis. Also has Claire security scanning implemented. In my opinion, Harbor is a little bit overdosed. Okay, so Herman's saying there's this other project that you can go and check out. And I think that one's called Portis. Let's see if we can't find it really quick. Let's do Portis container and see what comes up. Claim control of your Docker images. So I think this is the one that Herman is talking about here. Looks like LDAP is supported. You can like actually go and audit it and see who did what. This is super cool. This is handy. Looks like it says the word secure, so you should trust it. But yeah, this looks like a cool feature that I've never heard of, but now I want to come and check out. That's why I love doing TGIK. So anyway, let's go back to our Kubernetes and Docker link here. Looks like somebody started to type something. I'm assuming it's Portis. Yeah. Whoever is typing, let me know who you are so we can send you free stuff. So let's see, Kubernetes in Docker. It's moving around on me because you're typing. Let's do Kubernetes and Docker here. Okay, so this is the project that everyone's been talking about. If you haven't heard of it, it's literally exactly what you think it is. It's a Docker image that behaves and basically is a copy of Kubernetes. So this is fantastically powerful because now I can run a Docker image on my laptop here and actually treat that like it's a regular old Kubernetes cluster. In the past, we had to spin up a virtual machine, and then once the virtual machine was up, we like loaded all of the Kubernetes containers, and we did all of the Kubernetes kind of magic behind the scenes, and then we poked a hole on our network and bridged the connection, and then we were able to use the API server via localhost. And that's how Minikube worked, but now we've taken it a step further, and we've actually packaged all of that up into this container that we're going to look at here in a second. And one of the things that I was excited about when I first heard about this was the fact that it's written in Go. So my thought here, and this is someone who is very infrastructure driven in like the way I think about Kubernetes. Like whenever I talk to people about Kubernetes and they're like, Nova, what is Kubernetes? I always draw a picture of like, here's a server, and then here's like the network, and here are the different pieces of software that run on the server, and I think very physical. So this instantly sort of triggered this, oh my gosh, I finally have a lightweight Kubernetes cluster that I can run arbitrary tests against. And I think that was one of the big use cases when the open source community came together and actually created this project. So if you haven't started yet, this is like probably my new favorite project on GitHub. I've already came in and made a few contributions. This is just this week. Let's see if we can find me. Here I am. I came in and made a few contributions just because I really enjoyed it so much, and I wanted to help out, and I wanted to use the feature that I coded on our episode today, which we totally are going to look at, and we're going to write ourselves a pretty cool unit test. Let's see what people are talking about. Robert says, awesome sauce. Katie says, hello from Seattle. Hi, KT from Seattle. I am KN, also from Seattle. All right. So Kubernetes in Docker. You can come down here in the repo. You can see what it is. It says kind is a tool for running local Kubernetes clusters using Docker container nodes. We all know my strong opinions about how the first sentence in the README should describe exactly what the tool is, and if you're really awesome, how to use it or what it is. Is it a CLI tool? Is it an API? Is it a service? Is it all of the above? And Kind does a really good job at keeping these first little snippets very descriptive and telling us exactly what it is. So that's another big +1 for the project as well. So it says Kind consists of Go packages implementing cluster creation, image build, etc., a command line interface, Kind, built on these packages, Docker images in which to run, and kube test integration, which is built on all of these, which is a work in progress. And if you click on kube test, you can come and see this is actually a part of the Kubernetes test infra project, which these are the Kubernetes tests. This is what we're using to test Kubernetes. Every time we do a build of Kubernetes, we come into this repo and we run pieces of software that do end-to-end tests against our cluster. And you can now see that this Kind project is being implemented into that broader kube test repository and the test infra repository so that we can start to use this to test Kubernetes, which is great, but we can take that a step further. We can not only test Kubernetes, but we can actually test arbitrary things in and around Kubernetes. So this would be really, really exciting for like anyone who, let's say they wrote a CNI plugin. Being able to write unit tests that create a cluster, install CNI, do some stuff to the cluster, pull some data out of the cluster, and validate that your CNI behaved the way you want it to. This is like life-changing. Like there's so many use cases out there where people really wanted an easy way to create clusters. I think I've written a service at least 3 or 4 times in my career where like Jenkins will go and spin up a Kubernetes cluster, we run some tests, if everything went well, we destroy it, but sometimes the destroy doesn't work and we leave resources in the cloud, and it was like this whole mess. And this sort of solves all those problems. So that's why it's exciting for a lot of people. So anyway, at KubeCon last week, I pulled this up. I gave people a slightly more condensed spiel than the one I just gave you, and I actually wrote a unit test in Go using Kubernetes and Docker. But we're going to go a little bit further in this episode, and we're actually going to look at the packages themselves that make up Kind, get an idea of how Kind works, and then we're going to look at implementing Kind as a library and also running the Kind tool from the CLI. So first things first, let's download the Kind tool if we haven't already. So let me close a couple of my terminal tabs here, exit out of this thing, exit out of that one, clear my screen, and bam. And let me zoom in. We can all see I spun up a Kubicorn cluster right before the episode, and now we can see if we have kind installed in my path. So yes, I already do have it installed left over from TGIK Live. Interesting factoid, somebody stepped on my laptop right outside TGIK Live, so I'm actually running on a brand new laptop now, which explains why OBS is a little bit wonky for me. But anyway, I don't really know what's installed on the system, because it's like half new and half not new, so I kind of surprise myself every time I check to see if something's there. So if we look here, we can find, where's the release? One release, but there should be an install section as well. If you have go and docker install, you can do this right here. And this is exactly that command, that first one I have highlighted, is how I installed kind. And then this is the command to create a cluster. And then both of these combined kind of give you this output that you're seeing here. So now that we have kind installed by doing that go get, you can see that we can do kind and like all of our Go programs. I feel like it would be really exciting to do a Go program one day that didn't look like this and didn't use Cobra commands, just because every one of our programs on TGIK always looks almost identical in the way that we display the information here in the terminal. So like maybe that's like a challenge for me. It's like maybe I can write a CLI that like has some really obscure command library that nobody's ever heard of and make it actually look and feel a little bit different one episode. Anyway, so we can do kind build, we can do kind create, kind delete, and kind get. So get is like kind of like our list here or whatever, similar to the CNAB get that we looked at 2 weeks ago. It was a Duffel, that was the name of the tool, but yeah, it was for the CNAB episode that we did. But that kind of works the same way. And if you were at KubeCon, you probably saw the keynote that some folks did, where they talked about the differences between where you want to put the verb when you're building command line tools. So if you look at kubectl, we do kubectl get and then the name of some resource, or kubectl delete, then the name of some resource. So you get that verb second and the name or the type third. In this case, we're kind of following that same pattern, and there's sort of pros and cons to doing things this way. The other option would be like kubectl pods list. Then you would do kubectl pods create, kubectl pods delete, like whatever. And we could do that here with kind. And from a software engineering perspective, that's actually a lot easier to program, because then your commands sort of like flow together like object-oriented programming. This way, it's just a lot of repeating yourself and a lot of confusion as the software engineers try to navigate all of these different verbs and actions that you need to keep track of. So just interesting factoids about KubeCon along the way. So anyway, we can do kind create clusters. So let's just start off with this, and then we'll look at the code and actually see what it did. So kind create cluster. And we'll do a dash help first so we can see the help menu before we do anything. It says you can do a config. Kind has a config file, so I'm sure you could write in some really cool kind configurations, which would be nice if you're trying to automate this and you have things that you need to keep track of. You can specify an image, so if you want to run a different Kubernetes in Docker image other than the default one, you can do that here. And then you can do name. So we're actually going to take advantage of name because we're going to want to make sure that we don't overwrite the same container instance when we start to create this from Go. So kind, kind create. I'll just do this. Doop. Kind create cluster dash dash name. We'll call it TGIK1 for the first name of our cluster. So you can see here, it's going to ensure this node image is actually pulled down on my laptop. I don't know if I have it yet. It says ensuring, but I think that means it's just checking to make sure it's there. So this is exciting because there it is. There's the Docker container. This is like the hard work of the project kind of bundled up into one artifact here. This is the container that you can run that mimics Kubernetes. And how you want to, containers are modular, and how you want to run it or where you want to run it is totally up to you. In theory, you could totally run this container in Kubernetes itself and have Kubernetes in Kubernetes. And then maybe even run Kubernetes in that Kubernetes, and it's just like a big Kubernetes party. But yeah, the Kubernetes in a container, first time we've really seen it. It's kind of a hard thing to do, but we're finally here now as a community, and this is exciting. Okay, so we can come in and we can actually see what it's doing here. It says it's creating this node, it's fixing some system mounts, it's starting systemd. Systemd is what's going to watch the kubelet. It's waiting for Docker to become ready, and it's starting Kubernetes. This may take a minute. And let's go and let's actually look at the source code and see what's going on here. So we'll do this in GitHub. Let me close this. And we'll start here in the command kind directory. So here are all of the verbs that we talked about earlier, and you can see for a software engineer, it's already starting to get kind of confusing. You come in here, and so we did a create, so you go into create, and then in the create, you have cluster, this other command. So if kind wanted to create something else later other than a cluster, you could have another directory here, like maybe you could do kind create kubelet only or something. So here's create cluster.go, and so this is the command that we actually ran. Oh, there's a cute panda here. That's really adorable. I know some people who really like pandas. So anyway, we have package cluster, and we have our imports, and let's scroll down here to this new command. Okay, so here are the command line flag definitions that we looked at earlier when we did kind create cluster -h for help, same as --help. And you can see here we have this retain, we have image, we have config, and you can see that we passed in name as one of our options there. So here at the bottom, you can see we have this run e function here, and that's defined up here in run e for Cobra. And this is actually the entry point for eCode. So this is where the code starts based on that command that I just ran. And we're not going to go too deep here, but this is actually the code that I used to kind of borrow from when I looked at writing a unit test with kind. My logic here was like, oh, if they can build this into a Go program, then so can I, and I can use that Go program to do anything. So let's actually go and write some unit tests. So the way this thing works is you get a config, which is this is what's loaded here. And if you have a config file, you'll get it from the command line flags the user passed in. And then it'll call config validate. And I think if you have an empty config, then thumbs up, you're good to go. And that's what happened for us. Otherwise, we do some error handling, and that's all here. Let's see, somebody said something. Bergdis says, oof, grammar. Bergdis is our Icelandic friend talking about the grammar in English. That's kind of funny because I've been trying to brush up on my Icelandic for this trip, and yeah, it's not easy. So anyway, let's see what Saeed said. Saeed says, so instead of enabling Kubernetes on my Docker for Mac, I could just run Kubernetes in a container with kind. That's absolutely true, Saeed. So a lot of people, I don't know if I'll be able to show it, but in like the top right corner, this corner of your screen, there should be like the little Docker whale, and if you click on the Docker whale, you can scroll down, and if you have a recent version of Docker, you should see there's a little Kubernetes icon there, and then if you scroll over to Kubernetes, you can actually see that you have all your different kube configs, and that's how you're able to use Docker with Kubernetes. And this is just the community-driven version of Kubernetes running in Docker that the Kubernetes community put together. This is actually a SIG project. There is actually people in the open source Kubernetes community who are responsible for this, and they're really great if you want to go meet them. They were very receptive to my PR. Let's actually go look so you can see how nice these people were. So we can do closed. And let's see, where am I at? Kris Nova. Run meta information about a cluster. So I came in here and was like, hey, I have this idea. I got a lot of good feedback. We talked about it for a little bit. I had some questions. They answered my questions. They closed the issue. And if you actually come and look at my PR, you can see that the PR went through a pretty normal review process. A few people had some questions. We got some thumbs up. We kind of went back and forth. I eventually got a SGTM, and it wasn't a super big code change, and that came through. So it's relatively easy to contribute to Kubernetes, and especially with a project like Kind. If you're looking to get involved, I would strongly say Kind is a good place to start. It's really easy to understand. A lot of the hard part is baked into the Docker image, and this is just kind of making that a little bit easier for folks to run and basically putting training wheels on it, which is freaking great. So anyway, back to our code here. So we go into create cluster, create cluster.go. Bergdis says no code hamsters. Okay, so coming down here, we validated our config, we did some error handling. After with the error handling, we did this thing where we created this thing called a context. So we say cluster new context, and then you are required to pass in a name here. So when we do this in Go later, we're actually just going to come up with a random string or something, and we'll use that for the name of our cluster. And then it says if no image is defined, treat the code a little bit differently. Otherwise, we're going to just do context.create. And this is it. The create method is the method that goes and creates a Kubernetes cluster. And you pass in your config, and you have this option. This is a bool for if you want to retain or not. And this is an int for how long you want to wait for before it times out. Which is very reasonable. And most of the configuration options are here in the config. And if we actually go into Kind, now we're going to leave the command line tool land, and we're going to move over into the the package land. You can actually see that we have this separated up into many different useful packages. Excuse me. If you come in here to cluster, you can see that we have context.go. And this is the file. Yep, there I am there. I did a lot of work on this one. And well, not a lot of work. I added a couple of things here, and we can see some of my code here in a second. But if you come down, you can see that we have this create context. So this is the thing we're passing into create. And then we have this function called create. Let's see if I can find it. Here it is. And this thing will, again, validate your context, which is good in case you, the user, are lazy, like me, and don't do it. And then it'll start to actually go and create your cluster. And there's this other function that's called CC provision control panel. And this is where the rubber meets the road. So if we copy that, we can paste it up here. And you can see here is the provision control panel. This is technically a method, and then you can see it takes a kubeadmin config path because all of kind is built on kubeadmin. That's how we start our clusters. And then you can actually go and see that, yes, we actually create a control plane, and we use kubeadmin internally to go and bring up a Kubernetes cluster. And here we have start, and then you can see here fixing mounts, and they have the mountain emoji. That just makes me really happy. And tying it all back together, if we go back to our terminal here, you can see fixing mounts with our lovely mountain emoji. So let's go back to GitHub. So this is the main start container or function here. So this is where all of the goodies are kind of glued together. So if you want to come and look at this and actually see how they're doing it, this is the place to look. So on KubeCon, I see Mirantis get a smaller project. Sin, I am not sure. Mirantis isn't ringing a bell off the top of my head. Anyway, if you have any more info, that would be helpful. Okay, so anyway, so here's where kubeadmin starts. You can see we pass in some flags to kubeadmin, and then we call run, and then we do some other post config hooks. We define a Kubernetes admin.conf, and you can see that it makes a lot of assumptions here, which is kind of okay, because really, if we're testing things on Kubernetes, we just probably don't need to test a very expensive or a very customized cluster. Kind of having the default de facto cluster is probably a pretty good starting point. And then in general, the project it's structured in such a way that we could start to pull some of these configuration options out and bring them up to the top of the package and put them in the configuration, or even take that a step further and pull them all the way up to the CLI and make it a proper flag that users can interact with. So now it's just an exercise of figuring out what folks need and what folks care about, and then baking that into this core library here. And that's sort of how the kind works, and the project is kind of structured. Sin says similar, not smaller. On KubeCon, I see Grantis okay, I see what Sin's saying. I think he's saying that the folks at Mirantis have a similar project. Well, that's interesting as well. I had just heard about this one from working in open source. We started using it for other projects is how I originally heard about it. Okay, so let's go back up. And you can see there's a lot of other packages here doing a lot of other things, but that was sort of the main one. And if you want to actually go and see how we interact with kubeadmin specifically, you can go and you can look in the kubeadmin package. Or if you want to look and see how we're configuring our nodes, you can go and you can look in the node package. But that's a little bit deep for today's episode, so we're going to come back up and we're going to look at what the cluster looks and feels like now that it's up and running, and then we're going to look at writing a unit test with it. Okay, so Goland. Let's trying to think how I want to do this. No, let's open up my terminal. Let's do this first. Okay, so this is now done. It says export kubeconfig, and we do kind get kubeconfig path name TGI K1, and this will actually define our kubeconfig, because right now, if I do a kget po, you can see that we have no resources found, and if I do a kget nodes, you can see we're actually talking to USOS 2. So this is a Kubicorn cluster running in Amazon. We're going to use this for etcd later. If we do this export kubeconfig, and now we do a kget nodes, you can see that we have one node, which is the kind TGI K1 control panel status master running. So this is just a master that can schedule on itself. So we have one technical Kubernetes node. It's just running in a Docker container. So that's pretty cool. And then if we actually do a Docker PS, we can see that we have kind test node version 1.12.3 running into user local bin. And that's been up for about 10 minutes. And you can see here's our container ID. And then, so now that the container's up and running, we're actually able to interact with it as well. So Nader says the Mirantis one is Docker and Docker. I added a link to the HackMD. Thank you, Nader, or Nadir. I'm not sure how to pronounce that, and I'm sorry if I got it wrong. So anyway, this is the This is the kind container here running. Okay, and you can see that we've actually got this ephemeral port, 51016 is what the control plane is listening on. So if we go and we look in the source code here, let's go back to our package, cluster, context.go. Let's grep for the word port. Import, export, API server port. Okay, so this is one of the things that I coded. And all that we pulled out here is the API server port. And now we actually return this control plane meta that you can get out of the context that you originally created to create your cluster, like we saw in the command line implementation of this. And now you're able to get this ephemeral port out so you can programmatically build tests against it. So before, when I demoed this last week at KubeCon, I just copy and pasted the port after I started a cluster, and that's how we did it. In this case, my Go unit test that I have written will actually go and figure out the ephemeral port for you, so there's no copying and pasting, and you can totally automate the thing. So that was really handy. So Sin says cool. Okay, cool. So let's close that, and let's go to this new project. If you come here, under Kubernetes and Docker is Kris Nova kind testing. So this is not like, I'm not announcing a new repo, this isn't a new project or anything. This is just me like trying to consolidate my thoughts and get things into a place where if I need to in the future start building on stuff, I have a place to do it. But pull requests are accepted. So anyway, what we have here, this is open source, is we have just a very simple API test.go and a main test.go, and then we have this package called assertion, and that's all that's in here. If you go into assertion, you can see there's just one file. And the whole point of this is to show folks what it could look like if you wanted to write an extensive unit testing suite with Kubernetes and Docker, and if we wanted to start maybe as a community defining some commonly used assertions that we could plug into our unit testing suite to do things like assert container is healthy. Things like that. That would flip a bool yes or no and then give you a response, maybe an error message that came back, so that we could start building really elaborate unit tests that we're basically using as integration tests in Kubernetes, and we can make them specific to applications in the application layer of Kubernetes, which goes a bit further than the infra tests we looked at a little bit before. So this is like literally a way you could unit test your app running in Kubernetes, but like running locally in a Docker container. So this is pretty exciting. So let's pull up my IDE. So here's kind, so we're not going to look at kind. Here's TGIK, we don't want to look at TGIK. Let's see what we have here. Let's do Golang file, open recent, kind test, this window, whatever. Okay, so anyway, here's our code that we have, and then here's my terminal, and we're going to go into the kind test directory. So change directory, home, go, source, github.com, Heptio, or sorry, not Heptio, Kris Nova, kind test. Somebody said, Bergdis, let's learn Go for Kates. Yeah, if y'all want to learn Go, this is a great way to do it. Also, the Go Playground is a good way to start, and the tour of Go. So this is whenever people ask me, I'm just going to go off on a rant here. Whenever people ask me, Nova, what's the best way to learn Go? This is my answer always. It's called the tour of Go. It's how I learned Go. It's how a lot of people I know have learned Go. It's put together by the Go team, and it is super great at getting started from the world's simplest hello world, and you can just go through these like small chapters. Let's pick a language here. Where's English? I don't see English. Simplified Chinese. Oh, it just says next button. Okay. Go offline. Okay, so it'll give you examples, and then you can actually go and you can run them over here on the right, and then you can actually get an output. So as you go through, you sort of get like documentation. You get used to reading the Go docs, and then you can come in and actually run things and tinker around with it and try new things. So that's like the intro, and then here's where things get started, and it explains what a package is, and how imports work, and how you can export names, and why some functions are capitalized and other ones aren't. And you can go through and you can run this stuff. So I'm not going to go through it today, but if you want to learn Go, that's a really great way to start. Okay, so back here, we're now in our kind test directory, and let's look at our code a little more granularly. So we have two files here. We have main test and we have API test. So the point of structuring the repository this way is so that we could start to create a number of test files and separate our code arbitrarily using this format here as some type of test that's important to you in your application, underbar test.go, and then you can come in and you can actually write a test file that will automatically get ran. So the way that Go testing works, if you go to the main test here, there's this magic function called test main. And if you define test main and you run Go test, Go will use reflection, look back at your testing source code and say, aha, you have this special function called test main defined, and it looks like you're accepting the testing main, a pointer to that struct. So you can actually define whatever logic you want for setting up your unit test. So what we do here is we're actually able to like configure a logger, and then we'll go through this again in a second, but we actually are able to create a Kubernetes cluster, and that's this. And then here's, remember I mentioned we had to get the port out. That was the feature IPR'd. Here's the code that does that. And then we have this mrun command, which this actually runs the Go tests the exact same way that the Go test command line tool would. And Go run will actually go through and look for, in all of these files, anytime you have a function that starts with capital test and then has a name and accepts a pointer to testing.t, Go will go and run these for you. So we're able to just build as many of these functions as we want and test as many things as we want. And because we're using test main, which doesn't have to be defined, you can just not define one and Go will just do this mrun thing for you automatically. But because we're doing this, we can put in logic before and afterwards that allow us to make some assumptions while we're writing unit tests. So let's look exactly what our test main does. It says logger test mode is equal to true, logger level is equal to 4, context is equal to cluster.newContext cluster name. So we want to give this a meaningful name. So this is a constant defined at the top. So let's do cluster name is equal to TGIK2. Kubernetes in Docker node image. I think this is a bad name, so we want to do, well actually we'll just keep it for now, but it's not Kubernetes in Docker. Well, anyway. Okay, so kindset node, version 1.12.2. Okay, so we'll keep that the same, and we come down here, and we pass that in for image. Mozaffar Hago says, what theme are you using on Visual Studio Code Editor? So this is a great question. I do not use Visual Studio. I have reasons for that, but that's a different talk for another day. Feel free to find me at a conference. I'm happy to tell you why I don't use Visual Studio. I use a tool called Goland, and this is an open source tool that you can go and you can buy, which I actually paid for it. I rarely buy software, but I support this project 100%. A lot of my good friends in the Go community work on this, and you can actually go join the Slack channel, and you can go and talk to the people who are actually writing this and get really, really great feedback and great answers. So if you come here, you can do About Goland, and you can see it's licensed to Heptio Kris Nova, and it's running the OpenJDK, and it's powered by open source software, which is exciting. So if you ever get a chance to meet anybody who works on Goland, which used to be called Gogland, it's a good IDE, and I swear by it. I love this thing. It's great. Okay, so Herman says, added the Tor Golang link and the correct Portis link to the HackMD. Thank you very much, Herman. So looking in here, we define our Kubernetes and Docker node image. And then what's an interesting feature of Goland is at the end of the struct here, you can actually do a period. And you could chain things together. So because of that period, you can actually see all of the, and let me resize this so folks at home can see, all of the different fields you could define in your struct. So we defined image already, and we can see that that's a string, but you can also define control plane and have a pointer to a control plane struct. Or even the API version. So this is so fantastic because if you want to test your application on multiple versions of Kubernetes, you could just come in and change the API version here from version 1.8 to version 1.9 or whatever, and then you would be able to run a whole unit testing suite based on the different version. So that's really handy. And you can come in, you can actually define, like, you can add kubeadmin config patches and JSON, and you can see the rest of the object functions here that are defined. So for this example, all we did was define image, and we're going to keep everything else the same. Icarus says, is Golang just basically another JetBrains Suite IDE, or is it very different from the rest? So the reason I think the reason I like Golang so much is because it's very similar to the other IDEs that JetBrains comes out with. I don't want to admit it, but I'm just going to admit it. I used to be a full-time Scala developer before I wrote Go, and I got very familiar with IntelliJ way back when, and I just still love it. And before I used IntelliJ, and this is hats off to my friend Chris Anichek at the CNCF, I used Eclipse. So my whole life has been very IDE driven in the Java department, and so now I just found something that works for me in Go, and I love it. So anyway. Retain is equal to false. Wait is equal to time.duration of 0. So we're going to pass in 0, and I think that just means wait indefinitely. And we're going to set retain is equal to false, meaning we don't want to retain our cluster when we're done. And then next, here it is, that context create function that we looked at in the source code. We pass in our config, our retain, and our wait, just like the CLI implementation did. We do a little bit of error handling. And then afterwards, you can see how we are able to get this control plane meta out of our context. So this is the feature I coded in, and I think it's gonna like ultimately have getters and setters instead of using an exported function here. We can tell this is exported because it's capitalized, which means you can reference it from a different package. So it's basically like a programming API. So anyway, I'm lazy and just coded in like the poor, like cheap approach, which was just to make everything exported, so which is the equivalent of like a public function in Java, so that we can access it outside the package, just so I could demo things on TGIK. So anyway, in here you can see that we have that one field that I defined, which is API server port. But I think the goal of the project is eventually to get all kinds of good meta information back from the control plane that you might need to use if you're ever trying to not script things, but build a program that vendored the kind source packages. So anyway, we define our port, and then we have this variable defined here called API port. It's a string that's set to nothing, and so then we just override that string here, and we set it to whatever our port is. So this is just an ephemeral port. It could be anything, in the normal port range, 0 to 65,258. If I got that right, somebody like tell me. Anyway, go tests here at the bottom. It's going to do our run and run our tests. And then we did a defer up here immediately after we created our context. That does a context delete. So the way defer works is this runs, it's called concurrently in Go, and that would actually run at the end of our function. So after this exits, we're then going to do a context delete as long as we didn't OS exit here. So that's the way that defer works. So we're cleaning up our cluster at the end as well. And actually, just to kind of prove that, we can do exit code is equal to this, and we can just do print line exit code. Bam. And so now we can just see at the end of our program what our exit code would have been. That would always exit 0. Let's clean that up. And one of the things I really like about Goland is if you save it, it'll like auto-format your code for you, so I just never have to deal with Go fmt or anything like that. Okay, so that's creating a cluster and then running our unit tests. Let's look at a unit test. So I wrote the world's simplest unit test at KubeCon, and then I just copied that into here. And this is in the TGIK repository. And this whole function, basically all it does is it just opens up a socket against the API server, whatever port it's listening on, and just says, hey, I was able to open up a TCP socket. So that's going to validate that like we have all of our ports defined correctly, that the API server actually started and is listening to requests, and it doesn't do anything further than that. You could maybe take it a step further and maybe create some temporary dynamic configuration and validate that you can authenticate with the API server, but this is just opening a simple connection. So you can see that already we're starting to build these pretty complex tests, and we can bake a lot of these in here, which is going to give us some resilience and some confidence that our Kubernetes cluster not only is doing what we want, but our application running on top of our Kubernetes cluster is also doing what we want. So we'll sort of explore what it would be like to write a unit test for this CVE, do a regression for that, and then talk about like maybe an idea for testing like a CNI plugin. I think that's a good example. So anyway, this first one, it just says success is equal to false, and it just sits here, and it just hangs and tries to hit the API server, in case we're waiting for like the API server to come online or something goes wrong. And you could obviously change this logic if you wanted to. The original code for this, I want to like give credit where credit is due here. I think I wrote it. I want to say I wrote it, but I don't really remember. If you go to Kubicorn, we have this whole testing suite here. And this is this was what I was talking about earlier with like the noise of having to run all of this stuff in the cloud. And if you go into Amazon, clustertest.go, you can see, where is it? Test API listen. And this is a very simple test API is listening. I think Liz actually came through and simplified this a bit for us. And I think Liz also, this is the same person who did the Postgres video, the 5-minute one we looked at earlier. She works here with us. She also did this test git nodes. And so this just does like a Kubernetes git nodes. And that just validates that like maybe the API server is working. So you can already see that we have different ways of doing things. And where sort of some of these ideas came from is actually a tool that people actually use to deploy Kubernetes. Okay, so going back here, we do our API listen, and then we do a fatal here on line 33 if something goes wrong. Otherwise, we don't do anything, and we just move on to the next unit test. Okay, so here is this file called something.go. We'll talk about what we could write in here later, but let's go ahead and let's run this and actually see what's happening while we're running our testing suite. So how we would do that is we would do go test, and you can just do a period, and that says just load up all the things in this directory and test them accordingly. And so why we do that, let's zoom out here, zoom in here, recenter that, clear here, and now I can do an htop. Oh, I don't have htop installed because, actually, let's just do psaux. That's fine. Psaux grep for Docker. Let's do grep for kind and see what we get. Is the kind still running? Basically, all I'm trying to do is show folks that we can get, we can have multiple containers here. And we can just do docker ps, that's fine. So let's do docker ps, pipe that to, do I have watch? I don't have watch. I haven't installed anything on here yet. So let's do docker ps, and we'll just run that a few times in the right manually, the lazy way, since we can't pipe to watch. So anyway, we'll run go test here. And at first you'll notice nothing is happening. And that's because of the way that the Go unit testing libraries handle output coming back from your tests. So the way that it works is that it buffers all of the output that would normally be going to standard out or standard error, so that you can use different writers to actually write standard out and standard error too. So a really great example of this is taking like your tests, and instead of writing to standard out in the system, is actually sending all of those standard out messages, opening up a socket and sending that to some logger somewhere, so you actually get those logs at a different place. So it allows you to like have normal logging like you would write for your application, but you're actually able to like intercept that and pipe that somewhere else if you need to. And that's just a really clever part of how Go works. So anyway, while this is running, it's going to actually go and spin up a container. After the container spun up, it's going to run our test against the container, and then it's going to come back and say if it's OK or it failed and what happened. OK, so here it is. It's OK. And so we didn't get any of that standard out because we didn't redirect it anywhere. But if we wanted to go into the unit test, we could actually pull it out the standard out from the logger that kind is doing. But anyway, we got an OK. So let's, I missed it. Let's run this again. I wanted to show folks. Oh, because the container's already up. OK, so this is cool. So let's do a docker ps. Do we have more than one container? Why was this second one so fast? This one's been up 28 minutes. No, so we don't have a new Docker container. Let's try to do, let's change this and see what happens. I'm still kind of learning how kind works, so bear with me. Let's go here and let's do TGI K3. And let's open up our terminal. So now we do, let's clear this. Now we're going to do go test again. OK, so this one's taking longer. So I think we need like maybe ephemeral names for our clusters or something. So anyway, here on the right, if we do a docker ps, we should see, OK, yeah, now we have two containers running. We have one that's been up for 8 seconds, and we have one that's been up for 29 minutes. So the one that's been up for 8 seconds is the one that we're actually spinning up here. And once that's up and running, we're actually going to get the API server, and we're able to interact with it. So how we could use this to test our applications, and you can see how fast this is. I'm able to create a brand new, perfectly configured Kubernetes cluster, run arbitrary code against that cluster to validate things are working, and then clean up my cluster after I'm done, all within about 30 seconds here, which, to be honest, the Kubicorn tests are about a 20-minute long process. So this is a pretty drastic improvement here. So if we look at our code, we can come in, and we can see that we have test main, and we run our tests, but we want to look at something.go. It says, Glenn, go just fetch the cached result from the first test. Oh, I see. OK, so Glenn is just saying that because nothing has changed on the system, Go just didn't need to test it again and just returned the cache result, because I think Go does like a unique like hash for every time you do a test or whatever to see if you've already ran it or not. And that's how Go tests things so quickly if needed. Changing the name of the cluster effectively worked as a cast bus. Yeah, okay, so that makes sense. Thanks for the clarification there, Glenn. So here in something test.go, and we don't have time to do this because I want to move over to etcd, or at least talk about etcd and how you could implement it. We don't necessarily, yeah, we can probably get an etcd cluster up and running. We'll see what we can do. I want to talk about an idea for like if we were writing a unit test for a CNI plugin, or for your business logic that you and your company would be running. So here we would know that we could write any function that basically looks like this. So we'll copy this. And we're going to kind of write some pseudocode here. So here we have this function, and let's just say we want to do test CNI. Okay. So all we would want to do here is we could open up Kubernetes client, open up a connection with the API server. So we would use client go to talk to the API server. And probably before this, maybe up in our test main, we would have maybe some RBAC rules set up so that we can only talk with kubesystem from this test or this set of tests or something like that. So you can really see the flexibility that building these unit tests could give you. But we would get credentials for API server. I'm going to do somehow. So if you wanted to create those with RBAC and then pass them into this unit test, you could. Or if you just wanted to use your root, that's a personal decision. That's up to you. You should use RBAC. So anyway, client go to talk to the API server. And then here maybe we want to do a couple things. Maybe we want to list pods and check if a pod name exists. Maybe we also want to get information on that pod, do a get pods, and check the status. And just see, is it ready? What's going on there? We could even take it a step further, and we could get the logs for a pod, and then we could go in and we could do a string compare, strings.compare, and see, or a string contains, sorry about that, string.contains, and see if there's specific strings that are showing up in our logs to validate that maybe something's happening behind the scenes. So now, as you're building your applications, you can actually go and run these things in Kubernetes, and you can test not only things at your application, but you could actually test and see if you were writing an operator, does it install itself correctly? In fact, if we talk about etcd in a second, we're going to look at the etcd operator. That's probably a pretty good example of one of the things that I personally would really like to test with this Kubernetes and Docker testing capability that we have here, which is going through and saying, okay, let's first validate that the operator is up and running. Let's then create a new CRD for the operator, and then let's go and check and see if it actually went and did what we expected it to do. So you can start to really bake those tests together and really validate that your program is doing exactly what you want it to at the Kubernetes level, which is above your application level. So this is just really exciting. So I hope folks are getting ideas of ways they can start testing their applications using this. So I'm going to go ahead and move over into, actually let's do one more thing before we move into etcd. So now that we have a cluster up and running, if we do our Docker PS again, let's run here. You can see we have the one cluster that's now been up for 33 minutes. We can actually use kind to get meta information about that cluster as well. So we can do kind and we can do kind get. And let's clear this, kind get, and you can see we can do clusters or kubeconfig path. We did the kubeconfig path earlier to get our kubeconfig that we exported, but let's do clusters. Kind get clusters. Okay, so this is so beautiful. If you've ever looked at the cluster registry work that's going on in upstream, it's basically this. It's a place where you can go and register kubeconfig and cluster information, and kind of is a really concrete example of what this could potentially look like moving forward. We talk about this a lot in the cluster API, but it's basically kubeconfigs as a service, if you will. So we're able to do that using the kind command line tool. Let's see what else this thing can do. It can do delete, and it can export, and it can do a build. Which I think build is how you would actually go and create a Kubernetes image, and if you wanted to create custom images, you certainly could. Bergdus says all the kindness. Yes, lots of kindness. Glenn says such a great name. I really do like it. So anyway, let's move over into etcd. And if folks have questions about the kind, feel free to drop them in the chat. And I'll try to go through etcd pretty quick because I got to get to a doctor's appointment after this. So I only have about 15 more minutes before I got to shut it down for the day. But I do want to show folks some interesting primitives in etcd that really inspired how Kubernetes was created and how a lot of the Kubernetes system works and why it does work the way that it does, which is because of the inspiration from the database layer, which is kind of the core of Kubernetes. So Mozafer says any ID. Unsure what that means. If you could clarify, that would be helpful. So anyway, let's go back to our hackmd. I'm going to close a bunch of this while we're here. And you can see there's a lot to learn here about etcd, but don't be overwhelmed. We're going to kind of go through in high level each one of these things, and then we'll kind of go and see what they actually do. So the first and foremost, etcd. This is it. This is the database behind Kubernetes. Every time you interact with the Kubernetes API server, this is like anytime you do a kubectl get pods or anything, you're effectively fetching information from this database called etcd, and then the Kubernetes API server is processing that in some cases and returning that information to you according to your request and what you're authenticated to do. And that's basically how the API server works. And what's interesting about Kubernetes is all of the Kubernetes clients and all the other bits and pieces of Kubernetes interact with Kubernetes the same way you do. So the kubelet will actually go and authenticate against the Kubernetes API server, and it too will get information out of etcd, just like a Kubernetes client would through the same API server. So that's really exciting. So anyway, you can come through, you can see it's a distributed, reliable key value store for the most critical data on a distributed system. Sorry, I have something in my throat. The whole point of etcd is for it to be distributed and for that you to get this sort of resilience of running a database across different instances of itself. This is handy in Kubernetes when we start looking at things like highly available Kubernetes clusters and what it takes to form quorum with an etcd set of instances. This would be one or more than one member of etcd. And etcd follows the rule of like you need to have an odd number of members because of the whole election concern. So most times when you look at running highly available Kubernetes, which is really just another way of saying highly available etcd, you want to do that with a number like 3 or 5 or 7. I think 3 is the most commonly used one. And then you can distribute those etcd instances across different fault zones or fault-tolerant zones or regions, or not regions, but availability zones in Amazon or even in your own data center so that you get some resiliency there and you can improve the lifetime of your cluster. And this is all possible because of etcd here. Muzaffar says, any ideas how to use this Kubernetes and Docker with Jenkins? If it was me, this kind test repository here, I would just write everything I want. To answer the Jenkins question, everything I want I would write in here, and then I would just do a go test in Jenkins, maybe even containerize this if I needed to. I don't know how that would work with creating something on the host though. But anyway, that would be how I would do it if I had to write custom logic. If you just need to like set it up, there is nothing wrong with a bash script. Somebody should tweet that. There is nothing wrong with a bash script. # Kris Nova. So anyway, where were we? We were talking about etcd. So anyway, etcd is a key value store, and the whole point here is that we can distribute it and get highly available data storage out of etcd, which means highly available data storage in Kubernetes. And when I say key value pair, let's see if I can't go to my doc cam here. This is just like how I think of key value pairs. So we've all seen YAML before. So a key value is just an association of a key name and some value. So if we were writing this in YAML, key value would be just like key value. Like maybe it could be a name. My name is Kris. And maybe like my favorite color is blue. Okay, so you could, sorry about the light, you can come through and you can see all it is associating a type. So this is like a row in a spreadsheet with some concrete independent value. And that's all that etcd does for us. And with these key value pairs, we're able to define all of the Kubernetes objects because this is exactly how key value pairs work in Go. So we're able to like store those very well in etcd. In fact, I don't think that was an accident that it worked this way. So that's how Kubernetes is able to take advantage of this so easily. So Muzaffar Hago, I was wondering on how to test my K8s hosted Jenkins instance with this kind of thing. There's nothing wrong with the bash script, but bash opens the door to a lot of wrong. Aaron brings up a good point here. Bash is risky, but if you do need to containerize something and you just need to kind of do like a first approach at it and iterate on it later, using bash is not always the worst idea. If some level of testing is better than no level of testing. And that's just my opinion. And if you look at my You Can't Have a Cluster Bleep Without a Cluster talk, there is a really great example in there from our friends at Zalando over in Berlin where they decided to, well, I don't know if they decided, but they didn't have some testing in place. And I'm sure they all would have appreciated a level of bash there when their entire system went down because of something unrelated. But anyway, yeah, Aaron's right. Bash is scary. You should write Go if you have time and you can, because that's going to be way more secure. And this is a great example of how to do that. Sorry for the tangent there. Anyway, let's get back to my screen. And that's etcd. So the next thing, let's talk about I'm trying to think how we want to do this. Let's do the etcd client next. So this is the etcd client. In other words, this is the code that I'm going to be vendoring, that Kubernetes vendors, that you would actually allow you to go and interact with etcd from a client-server model perspective. So this is the client code. It's interesting because etcd doesn't have its own client repository like Kubernetes does. It's actually a part of the main repo, and I think it actually uses it itself in a lot of cases. So that's the client code. So if you do plan on vendoring etcd in Go or interacting, like if you want to go make a contribution to the Kubernetes API server that interacts with etcd, this is the library you would be interacting with. Okay, so next we have etcd Cuddle, or etcd CTL, or etcdactyl. I don't even know how you would, like etcdactyl. Maybe we can call it etcdactyl, like a dinosaur. So anyway, this is just a command line tool that basically wraps up that client that we just looked at. So in the same way that Kind has a command line interface that wraps up the underlying cluster package that we looked at, etcd has one as well. And you can actually come through and you can see here's all these command line examples of etcd put foo, bar, and then you can give it a lease. And this is just saying remember we looked at key values earlier? Put the key foo with the value bar, and then you can do get foo, and it's going to return bar. So here, this would be name is equal to Nova, etcd cuddle get name, return Nova, or Kris, or whatever. So let's see here. Berg just says, oh, cuddles. I like Berg's commentary. It's kind of nice to get like some fun examples along the way. Okay, so this is the etcd client. So next we have the etcd operator. So let's go back in my terminal. We're going to exit out of this left terminal here, because this is the one that had that kubeconfig exported. So now if we do a kget nodes, we should be back in Amazon, which we are. So now let's go to etcd operator here. And I think we can do, there's like a installer guide. I really should have done this beforehand. Okay, so we want to do this create, or where's RBAC? We want to do RBAC first. Okay, so here's our RBAC. So you want to come through and you want to set up RBAC. Honestly, I don't know if we're going to have enough time because I got to go. I can just walk folks through what I did to demo etcd, and then if you want to go through and actually do this on your own, you can. And maybe I can do a more involved episode next week on etcd whenever we get back. But basically, you would come through and you would set up RBAC for your etcd operator. And you would run these commands here. Make sure you do a role name, make sure you do a role binding name, make sure you give it a namespace. You can come through and look at this cluster role template.yaml and said this is going to be in the example directory. So we will just kind of copy this, open this up in a new tab. And if you come and you look at these example YAMLs, I really thought I was going to get away with not looking at YAML today on TGIK, but it wouldn't be an episode of TGIK if we didn't look at YAML. So here is our, here in the RBAC directory, we have template, role binding template, and these other ones. And this just kind of lays out the RBAC rules and roles that you would be creating. So you go through and you want to create the cluster role binding. This is like an example of how you can sed, which is just a find and replace various role names into the template. And then after you have a template, you can you pipe that to kubectl create. So this is just like using bash to like automate this, like create a role and call it whatever you want mentality, which there's tools out there that will do this for you as well, like Kson or Helm. So then you create a role and you create a role binding. So after that's done, you should be able to come back here and getting started. You then should be able to do a kubectl create example etcd cluster.yaml. So if we look at that thing, example etcd cluster.yaml, you can see that it's kind etcd cluster, and it's the API version of v1 beta 2. And it says adding this annotation to make this cluster manage this cluster-wide operator. So this just gets our cluster ready. After we do that, we want to do an example etcd cluster node port service .json. Let's see, Berg just says wanting to buy more brain power. I'm sorry, I'll go quick here. I won't go too deep, I promise. And anyway, let's scroll through this. This talks about how if you wanted to do a node port service, we're going to skip past that. Here's the example of how to delete it, and here's an example of how to resize it. And basically the examples here that you're going to want to do are pretty straightforward. And all that really happens, here I'll go back to my dock camera here, is the etcd operator will get deployed as a deployment. This is an interesting thing because this is one of the first operators and one of the only operators to do things this way. So this is actually different than most operators, which is exciting to learn about. So the etcd deployment operator, the first thing it does is it goes and it creates the CRDs. These are custom resource definitions. And this is where things are different with the etcd operator. Normally, if you look at the operator pattern, like when we did the episodes earlier in the year about all the different ways you can write Kubernetes operators, creating CRDs was a manual task that you did before you deployed the operator. The operator will actually create its own self-defined CRDs as needed. So this is exciting. I also think that it does some configuration to your cluster as well to make sure that your cluster is set up and running if needed. Then it actually goes and goes into this loop here, which I'm going to kind of do this like event loop here, and we're just going to say this is an event loop. And that's going to kind of cycle until the end of time. So then, after that's done, with these CRDs that are defined, you can go and you can create a single example of one etcd cluster. So etcd CRD, and that's really etcd cluster CRD. And once you define this, it's actually cool because we're actually about to learn what really happens here because Kubernetes uses etcd. But in this case, there's this really exciting thing called a watch that will kick off this chain of events that this will eventually interrupt this loop. And that loop being interrupted will say, oh, okay, I have the etcd CRD, and then I should actually go, and now the loop will go and then create not one, but by default 3 etcd nodes. The reason we create 3 is because I mentioned earlier, it's a highly available database, and so by default we create 3 of these running in Kubernetes itself that then we can talk to later. You'll get a service that will map to all of these, and via that service you can then, the client, you can interact with that service, and then those will go to your backend etcd. And you do a service type load balancer, and it'll actually load balance across these, which is pretty handy because now we're getting a distributed database that's pretty easy to use. So what's cool about etcd is how the database works with a watch. If you've ever done any learning or researching about how the Linux kernel or any kernel, the FreeBSD kernel even, I can't speak to the Windows kernel. That's a big black box mystery to me. But the FreeBSD and Linux kernels and most Unix kernels are they're based on interruptions. So that's how we sort of take action and how we just kick off this chain of events. Every time you press a key on a keyboard, there's actually an interruption that occurs in the system, and the system attempts to recover from that interruption. Victor says, hi Chris, would love it if you can show us how to write a unit test for operator with kind next time. I'm using the operator SDK now. Okay, that's a good example. How would we write an operator using kind, which is so that we can deploy an operator and have it run our unit test for us. That's a good example, Victor. If you want to open up TGI issue on that, we can track it from there. Okay, so anyway, back to our diagram here. So anyway, interrupts in the kernel, that's how they work. We're basically mimicking that same system and that same behavior here in Kubernetes. There's a lot of good information about how Kubernetes and the Linux kernel are compared, and they talk about how distros are very similar and how the interrupt events are similar and how it's sort of declarative in nature. And it's actually pretty interesting to learn about the similarities between how Kubernetes works and how the kernel interacts with hardware and other inputs. Okay, so anyway, that's all possible because of this thing called etcd watch. And it's really cool. So let's actually write some pseudocode here, and we can kind of talk about what's going on. So we'll stay in the kind test. Actually, no, let's go to TGIK. So we'll go here to TGIK. We'll go to episodes. We want to do a new directory. We're going to call it episode 60. We'll add it to get, and then scroll all the way down, open up episode 60. And then in here, we want to do new Go file. We'll just call it etcd.go. And yeah, we'll add that. So this is package. We'll just call it etcd. There we go. So if we go to the etcd client code, so anyway, let me, I know I'm not on my screen here. If we went and did this, we would now have an etcd cluster up and running. And if we could either do a port forward on the etcd pods, which I think is how I did this for the demo, or we could interact directly with a service. But let's just skip past that and say that we have etcd up and running and configured since we're running out of time here. So now I'll go back to my screen in my face, and all I did here while I was working was I just created this package called etcd, and I just have a new workspace set up for us to work in for etcd now. Okay, so if we go back here, you can see the etcd client that we looked at earlier. If you click on this, there's a great example here. If you want to use the client, you just do go get, and then here with this example, this is actually runnable Go code. here and here. So here in Goland, we can actually go and we can see what's going on. And give it a second. It's got to kind of load this client, and the IDE is going to start to like learn about it. Yeah, there it goes. And let's tell it which we want to use the Go context package here. So let's see. This one. So the way that Goland works is if there's more than one package in my Go path called context, you have to define which one. And then once it gets that, it'll know how to import it accordingly. And you can see here we have package main and the imports, and we're just going to get rid of that right off the bat. So here is our program that we can use to talk to etcd. So this is pretty simple. Basically, you would define, like if we did a port forward, this would actually work out of the box. We could hit localhost here. It's important to know that this needs to be 127.0.0.1 and not the string localhost. Don't type localhost there, you're going to have a bad time. I think even 0.0.0.0 causes a little bit of trouble as well. It's not a byte address, it's a listening endpoint. And you can have more than one. So if you're not sure, define all of them, and I'm sure one of them will be fine. At least for demo purposes, you should figure out which way and where it's actually listening if you're running this for any sort of serious production instance. Okay, so we do a client new config, which you see this new context, new config. This is a very common pattern in Go. We saw it in Kind. We're now seeing it from a completely independent project called etcd, and we pass in a config. Then we get our keys from the API by passing in our config, and then we have this KAPI variable here. Somebody said something. Moziffer says how much the license costs for Golang IDE. I think it was like $200. It wasn't cheap, but again, like I really support these folks, and I really like the program. So actually, I think Heptio bought it for me, but somebody, either Kris Nova dollars or Heptio dollars, paid for it along the way. So anyway, let's see KAPI. So you can come in, you can see all the different methods that you can interact with now that you've got an authenticated and configured connection to etcd. So you can create, you can set, and you can get. And so create is how you would create like a new key value. Set is how you would set a new key value pair, and get is how you would get that. But look a little deeper, and you can see there's this watcher thing here at the end. And this is very unique to etcd that you don't see all the time. Most databases don't have a concept of a watch. In fact, like the closest thing I can think of offhand would be like if we were able to do like a MongoDB cursor, and we would able to sort of like watch something and iterate over something as data came in. But anyway, this watcher is specifically designed to be event-driven and to be reactive in nature. And this example doesn't show you how to do a watch, but if you want to come down here at the very end, and I ran this on stage at KubeCon, and if folks want to see an example of this, I'm happy to help them get an etcd cluster up and running. So you come down here and you could do KAPI, and you could do watcher. So if we did watcher on foo, after that watcher, you can do watcher next. And sorry, let's actually see what this thing returns. It returns, I think it's going to return a node and an error. Let's see if I got that right. So with Golang, you can go straight to the definition. You can map that to your hotkey. It's called go to declaration. And you can see here it returns a thing called a watcher. That's all it returns. So let's go back to our code. Okay, so we don't want an error. We just want to change this to I don't know why that keeps coming up. That's really annoying. I think it's because I'm in presentation mode, so I'm just going to not use my mouse. Okay, so come here and go to watcher. So then after we have a watcher, we can do watcher dot next. And that takes a context. So if you ever need to pass in a context and you don't know what to do, you can just do context.todo. It's like the lazy person's way of passing in a context that doesn't really do anything. And then what else do we need here? Options. Okay, so for options, let's just pass in nil. Okay, so that looks happy. So now we can say watcher next, and at the beginning of watcher next here, now I think we can do node error is equal to this, yes. And then on the node, you can see we can do node, I guess it's not called a node, so let's just call this the response. Response, and then you can come in and you can do response dot node, and then in node you can see that you can go, you can get the key and you can get the value. So this is exactly how Kubernetes gets keys and value pairs out of etcd. What's exciting though is if we actually did get key and value here, and we did something with this. Let me scoot over here. I'm sorry that keeps popping up. If we scooted over, I'm going to comment this out just for now. Sorry, all my hotkeys are broken because I haven't remapped to my Emacs hotkeys yet. We came over, we could get the node, we can get the value. What's cool though is if we ran this, if I ran this program right now, the behavior would be, it would define foo, as it's defined up here on line 26. It would get foo right here on line 35, and then the program, if this was being executed here at the end, would hang. So nothing would happen, the program wouldn't exit, it would just sit there quietly waiting. And this is on the client side, remember. And if I, like, say, jumped into my terminal here and using, like, etcd cuddle or even a second Go program or some other client, I rewrote config value to the foo key, the program would all of a sudden read that and then exit after it read that. So it would be very quick, but because of that, we can actually build this watch into our code and stick it into an infinite loop and just say anytime something happens or something changes in the system, we need to respond on the client end. So this is client-side watch. This is really powerful, and this is how Kubernetes works. These are how operators work. These are how controllers work. This is how Google at Google Next was able to do the whack-a-mole thing, and people weren't able to beat the Kubernetes scheduler because all the client code has this built-in at the database layer watch that's lightning fast that allows you to be reactive when events happen in your data store. And the Kube API server does the same thing. Okay, so it looks like folks have some questions. Let's see what their questions are. Hi, Kris. Would love if you can show us how to write unit tests. Okay, I already talked about that one. Bergda says define food. Yeah, I need to go get some food too. Also, I'm 10 minutes past my time here, so I'm going to be late for the doctor. So I need to wrap up. Okay, so that's a lot of kind, a little bit of etcd. Sorry I didn't get a chance to do a little bit more etcd. We can look a little bit later. If folks have any ideas, feel free to let us know. I'll merge this code here as well as the kind test code into the repository with pointers to everything for episode 60. I've had a great day today. I hope folks learned a lot about kind and learned a lot about etcd, and also didn't want folks to feel like they were left out for when we did these 2 episodes at KubeCon. So now you got the first hand and actually a little bit more involved of a definition of kind and etcd than we did for TGIK Live. So questions say from Mozurfer says, is it possible to override watcher interval time through watch API? Yes, when you create the watcher here, I passed in nil for the options, but there's a ton of watcher options here. So I think they're called watcher options. That's actually really hard to say. So you can say that there's a recursive index. You can say recursive yes or no. You can say there's an after index. And I think there's different ways you can define other configuration for the watcher as well. Let's see what other folks are saying. Bergda says, very interesting. Aaron says, happy holidays. Thanks for your time as always. Victor Yang says, thanks a lot and happy holidays. Bergda says, even a little mind blown. Let's go back to my face here. Thank you all so much. I love doing this. I'm actually out until the new year. It's been a crazy year. We just went through the acquisition. We've all been working really hard. So I'm going to go relax. And my way of relaxing is going to be doing a little bit of ice climbing in Iceland with my partner. So I'm really pumped about that. I also got a new fancy camera. I got the Sony a7R III and a bunch of really exciting lenses for it. So I'm going to be taking some really high quality photos of winter in Iceland, so stay tuned for those as well. If folks have any questions or need anything, Joe and I will be back after the holidays. I'll make sure I tweet about it from Iceland and let folks know that there's not going to be a TGIK, but we're going to be back in January, and hopefully by the time we get back in January, here in our GitHub issue, let me switch over to this really quick. Where's screen and face? Here in our GitHub issue, I want to see if anybody's done anything yet. We should have some ideas for TGIK moving forward. Okay, so come add your ideas for TGIK, anything you would like to see, and we can start looking at how we can use VMware and leverage them to help improve TGIK, to keep this going and keep the hype up and keep TGIK alive. So we're really excited about that. So again, thanks everybody. It's been real. Let me know if you have any questions, and I will see everybody in 2019 with a bunch of sweet ice climbing and volcano pictures, as per usual. See you soon. Be safe and have fun. Happy holidays. Thanks for being an inspiration in 2018. You're welcome. Yeah, this year was a big year for me. Wrote a book, climbed a bunch of mountains, got a new fancy job twice. I wrecked my car, the Les Brew. So it's been a crazy year, and always happy to spend time with folks at home. So yeah, we'll see everybody soon. Thanks again. Happy holidays. I'm really going to sign off this time. Have a good day, everyone. Bye.